This is Unit 1, Section 3. Example 1. For each of the following, determine whether A is a subset of B. Then determine if A is a proper subset of B. So set A is the set New Bedford, Fall River, Attleboro. Set B is New Bedford, Fall River, Attleboro, Taunton. So New Bedford is in B, and it is Fall River is in, and Attleboro is in. Therefore, A is a subset of B. Is A a proper subset of B? Only if the sets are not equal. So if we look at A and B, A is a subset of B, and they're not equal because B has Taunton. So A is a proper subset of B. B. A is a set 1, 2, 3, 4. B is a set 1, 2, 3. For A to be a subset of B, each element of A must also be in B. Well, 1 is in, 2 is in, and 3 is in, but 4 is in A, but is not in B. So A is not a subset of B, so A is not a proper subset of B. C. A is the set with YouTube, Facebook, and Snapchat. B is a set with Facebook, Snapchat, and YouTube. Is A a subset of B? Let's check. Is YouTube in there? Yep. Is Facebook in here? Yes. Is Snapchat in here? Yes. So A is a subset of B because every element of A is already in B. Is A a proper subset of B? No, A equals B. So it is not a proper subset of B. Example 2. Determine if each of the following statements are true or false. A. The element A is an element of A, B, and C. That is true. It's right here, so this would be true. Here, it looks like the same statement, except we have B in set brackets. So the set B would be a subset of A, B, and C, but it is not an element because we would need this whole thing to appear inside here, including these set brackets. So this is false. The set B is a subset of A, B, and C. That, as I said earlier, is true because the set containing B has only the element B, which is in here, so it is a subset. So notice that's a subset, but not an element because the whole thing doesn't appear in there. Let's try the next one. The set containing C is an element of this set. Now this is true because the entire thing appears inside the outer set brackets. So this set here is a set with 3 sets that are elements. So this set here is a set with 3 elements. This element C is a subset of A, B, and C. This is false because C is not a set. Because C is not a set, it can't be a subset. Now the empty set is a subset of A, B, and C. That's true. The empty set, which is also written like a circle with a line through it, is a subset of every set. Example 3. Professor Devon is using Zoom to teach a class of 9 students. How many possible sets of these 9 students can sign on to class on a given day? And B, if she knows at least one will show up, how many different sets can there be? When we're asking how many possible sets, we need to remember the formula that if n is the number of elements in a set, also known as the cardinality of a set, then the number of subsets is 2 to the n power. That means 2 multiplied n times together. So in our case, we have 9 students in our set. Imagine a list of names. We could have Abby, Carlos, etc. in her set, and there'd be 9 students in that set. The number of subsets would be the number of possible sets of ways the students could sign into class. So it would be 2 to the 9th power. So you can multiply 2 9 times. 2 times 2 times 2. Let's see, 3, 6, 9 times. Or you can use your calculator to do 2 to the 9th power. Or you can use Google to do it. In Google, you would do 2 with a little bracket like this. This is an exponent to the 9th power. Any of those are fine. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, 32 times 2 is 64, times 2 is 128, times 2 is 256, times 2 is 512. I know most of you would prefer to use a calculator. Remember, it's 2 to the 9. Or on a calculator, you might have a key that looks like x to the y. So check that out. You should get 2 to the 9th is 512, and that can help you remember how your calculator works. Okay, so that was part A. In part B, it says if she knows at least one will show up, how many different sets can there be? So this says you can't have the empty set. This 2 to the 9th includes the possibility of the empty set. But this professor says, well, if nobody shows up, she doesn't have class. So she's going to say there are 512 ways, but that includes the empty set. So we're going to subtract the empty set as one of the possibilities. So there'd be 511 ways to do this. Example 4, determine if the sets are equal, equivalent, or neither. In A, we have the set of all dwarfs who spend time with Snow White, also known as the 7 dwarfs. Google it, you'll find them. And the set red, orange, yellow, green, blue, indigo, violet. So they're clearly not equal. They have totally different things in them. So equal is out. So are they equivalent or not? An equivalent means the same number of elements. So we know the first set has 7 dwarves. Let's count these. 1, 2, 3, 4, 5, 6, 7. So there's also 7 in these colors. And so these would be equivalent because they have the same number of elements. How about this set? This set has FACE, 4 letters, and this set has ACEF, so it also has 4 letters. So it would be equivalent or equal. Now we got to see which one. They're equal if they have the same elements. So let's see if they do. We have F here and F here, A, C, C, E, and E. So these sets are equal because they have the same elements. And for the bonus question, why these letters? If you look at a sheet of music, okay, so it has the 5 lines in a sheet of music, and you look at the treble clef, I haven't drawn one of these in a long time, like that. These notes that are the spaces are F, A, C, and E. So if you're a music person, you probably know that. Not required to know that for this class.